Hello everyone. Today we're going to solve some of the problems from the chapter current electricity. So I have considered a problem which is from one of the model question papers. Okay, so this is one of the important problem. The problem says a copper wire of 3 meter long carries a current of 3 ampere. The area of cross section is 2 into 10 to the power of minus 6 meter square, and the number density of free electron in copper wire is 8.5 into 10 to the power of 28 per meter cube. Calculate. So there are 3 things which you need to find out. So the first one is current density. Okay, so before I start calculating, I'll just write down what all they have given in the question. So they have given the wire of the copper, or the length of the copper wire. So the length of the copper wire is 3 meter, and then they have given the area. The area is 2 into 10 to the power of minus 6 meter square, and then they have given the current. Current is 3 ampere, and then there is number density, small n. So that is 8.5 into 10 to the power of 28 per meter cube. So here the number density is basically the number of electrons present in per unit volume. Okay, if this is the copper wire and this is the length of the copper wire, that is 3 meter, let's say. Okay, so in 1 unit of volume, how much electron is present? So that is number density. Okay, so let's find out the first sub question, that is current density. First you need to find out the current density. Current density is denoted by small j. So the formula is amount of current flowing through the conductor per unit area. Okay, the amount of current passing through per unit area of the conductor is nothing but current density. So do we have the value for current here? Yes, they have given the value for current. Do we have the value for area? Yes, they have given the value for area as well. So can we directly find out the value for current density here? Yes. So that is, current is 3 ampere and area is 2 into 10 to the power of minus 6. So what is the value? Is 1.5 into 10 to the power of 6. Why? This exponential term, it goes to the numerator and it becomes plus 6. So what is the unit for current density? So the unit for current density is ampere per meter square. Okay, if in case if you don't know the unit, so look at the formula. You will know the unit for current, that is ampere, and you will know the unit for area, so that is meter square. Hence you can write it as ampere per meter square, right? So you have got the value for current density. Let's move to the next sub question. So the next sub question is, next you need to find out the average drift speed. So second is average drift speed. Okay, so you need to find out average drift speed, or you can say average drift velocity. Okay, so there is an equation which is relating current and the velocity, drift velocity. So which is that equation? So the equation says I equals to current is proportional to drift velocity here. So I equals to number density, charge of an electron, area of cross section, and then there is drift velocity. Okay, so here you know the value for current, you know the value for current density, you know the value for number density. Then there is E, charge of an electron. Here they have given the charge of an electron. So the charge of an electron can be written as 1.6 into 10 to the power of minus 19 coulomb. Okay, so this is either they'll give the value for charge of an electron, or you need to know it. Okay, so it is constant, so you need to know it would be better if you know the value for charge of an electron. So or else they will give it in the problem. So now we know current value, we know number density value, we know charge of an electron value, we know the value for area as well, but we don't know the value for drift velocity or drift speed. We need to find out the value for drift speed here. So rearrange the equation, and this becomes I divided by number density, charge of an electron, and area. So what is the value for current? The value for current is 3 divided by number density is 8.5 into 10 to the power of 28. I'll write it here. Current is 3 divided by number density is 8.5 into 10 to the power of 28, and then there is charge of an electron, that is 1.6 into 10 to the power of minus 19. Then there is area. What is area? Area is 2 into 10 to the power of minus 6. So now you need to find out the value for drift velocity. I'll continue here. Okay, so now drift velocity equals to, so there are too many exponential, too many numbers, so I'll make it easy for you to calculate. Just separate the numbers and separate the exponentials. So here I'll take 3 divided by 8.5 into 1.6 into 2. Okay, and the rest of them, let them go to the numerator. So when it goes to the numerator, 10 to the power of 28 plus 28 becomes minus 28, and then minus 19 becomes plus 19, and then minus 6 becomes plus 6. So you can easily calculate the numbers as well as the exponentials. So now what is the value for drift velocity or the average drift speed? So the value for drift velocity is 0.1102 into 10 to the power of minus 3 meter per second. Okay, or you can write it as 11.02 into 10 to the power of minus 5 meter per second. What have I done here? So I have just multiplied and divided by 10 to the power of minus 2 to get better looking answer. That's it. You can even keep it this way, or you can multiply and divide it by 10 to the power of minus 2 so that you can get better looking answer. That's it. Okay, so this is your answer for average drift speed. So then we'll move to the next sub question here. So the next sub question says the time taken by electron to drift from one end to the other end of the wire. So if this is the copper wire and electron has to drift from here to here, so what is the time taken by the electron to travel from here to here? So one end to the other end. So here you have already got the value for drift velocity. You know the formula for velocity from your last class in the sense when you were in first PU, you have already learnt about velocity, time, displacement. So what is the formula for velocity? So velocity is displacement divided by time taken. So displacement here can be written as length and time taken is taken as time taken. Since we know the velocity value here, velocity is considered as drift velocity, so we know the value for drift velocity. Now we'll again rearrange the equation. So the equation becomes, the formula becomes T equals to L divided by drift velocity. The length of the copper wire is 3 meter and the drift velocity which you have got here is 11.02 into 10 to the power of minus 5, right? So this is the time taken here you have substituted the value for length as well as the drift velocity. So the time taken can be written as, when you substitute it, the value will be 0.27 into 10 to the power of 5, or you can write it as 27.22 into 10 to the power of 3 second. Okay, so here we got the value for time taken. One thing I would like to say, that time taken can never be negative, okay, because it doesn't have any direction. It has got dimension, but it doesn't have direction. So time taken can never be negative. Okay, in case if you have got any negative value of time, so the whole thing, whichever you have whatever you have calculated, everything is wrong. So you need to correct your answer, you need to correct the solution as well. So this is one of the problems from model question paper. We'll move to the next problem. So the next problem is, calculate current density and drift velocity of conduction electrons in a copper wire of cross-sectional area 1 into 10 to the power of minus 7 meter square, carrying current of 1.5 ampere. Electron density of copper is 8 into 10 to the power of 28 per meter cube, and charge of an electron is 1.6 into 10 to the power of minus 19 coulomb. So this particular problem is similar to the one which we have just solved, and this is also from one of the model question papers. So we'll solve it. What do you need to find out here? So you need to find out current density and drift velocity. ಇಲ್ಲಿ current density ಮತ್ತೆ drift velocity ನ find out ಮಾಡಬೇಕು. ಏನೇನು ಕೊಟ್ಟಿದ್ದಾರೆ ನಮಗೆ ಇಲ್ಲಿ? So they have given the conduction electron in a copper wire of cross sectional area. So they have given the cross sectional area, that is 1 into 10 to the power of minus 7 meter square, carrying current of 1.5 amperes. So they have given the current as well. So current is 1.5 ampere. Electron density of copper is, so electron density is nothing but number density here. So n equals to 8 into 10 to the power of 28 per meter cube, and then they have given the charge of an electron 1.6 into 10 to the power of minus 19 coulomb. Okay, so first what do you need to find out? You need to find out current density, and then you need to find out the drift velocity. So what is the formula for current density? Current density is J equals to I divided by area. Current flowing through the conductor per unit area is current density. Okay, so the current density equals to current is 1.5 divided by area is 1 into 10 to the power of minus 7. So you don't have to calculate here, you can directly write 1.5 into 10 to the power of 7 ampere per meter square. Then the second one, what do we need to find out? We need to find out the drift velocity. So here again you will take the same formula, which is relating current and drift velocity. So the formula says I equals to current density, sorry, not current density, number density and charge of an electron, and then area, and then drift velocity. So rearrange the equation, that is drift velocity equals to current divided by number density, charge of an electron, and area. So what is current? Current is 1.5 divided by number density is 8 into 10 to the power of 28. Charge of an electron is 1.6 into 10 to the power of minus 19. And then there is area. Area is 1 into 10 to the power of minus 7. Okay. Okay. So I'll calculate this in my way. So whichever is comfortable for you, that way you can calculate it. So first I'll write down the numbers. So the numbers are 8 into 1.6 into 1, and then the exponentials. So 10 to the power of 28, when it goes to numerator it becomes minus 28, minus 19 becomes plus 19, minus 7 becomes plus 7. So calculate and get the value. So the value of this is 0.1171 into 10 to the power of minus 2 meter per second. Okay, since it is velocity, it's meter per second. Then again, so I'll multiply and divide it by 10 to the power of minus 2 so that I get better looking answer value. So that is 11.71 into 10 to the power of minus 4 meter per second, or you can just keep it this way as well. Okay, so I hope you have understood the problem. This is easier because we have already solved the similar one. So this is also from model question paper. So I hope it helped you. These two problems are really important, and we'll solve some more important problems, some more questions from model question paper, okay, in the next videos. So thank you. We'll meet in the next video.